So I think there's a number of different things that we're trying to accomplish with this conference. One of them, I think, is to bring together some of the leading people in this area to tell about their latest progress. Also, we're really thinking that this area will be of great importance for IEEE as well as the Engineering in Medicine and Biology Society, and we're trying to give greater visibility of the society to this research area. Another area that we think this conference will be good for is to bring really young and emerging students and try to show these young researchers, put them in a forum where they can interact with some of the leading figures and learn from them, and we think that it will be a great experience for them. I think there's a number of different things that people have developed to improve medicine using these kinds of tools. So one example that we will have a session on is to use microfluidic technologies for detecting the progression of cancer or AIDS. And the way this can happen is that people make microfluidic systems where a little drop of blood can be taken, and the little fluidic system can analyze the number of cancer cells that exist in this sample, or the number of immune cells that exist to detect the progression of AIDS. That's just one example. There's many, many other types of examples that people will describe also at this conference. The whole goal is to make functional tissues that can replace damaged tissues of patients. Major challenges in this area are probably twofold. One is our inability to get the right and appropriate cells that do the function of the tissue that we want. So that's why things like stem cells have been such an important topic for so many years. Another major challenge is, even if we have the right cells, then how do we actually go from cells to make functional tissues? And I think to do this, we need to address how to bring these cells together in a functional way and how to make them so that they behave and we can make them into large structures. How do we address issues like blood vessel formation and vascularization of these constructs? And how do we align these cells in a way that mimics how their organization is in the body? The success of tissue engineering, it depends on the organ that we're talking about. There's already commercial successes in artificial skin, for example. And the reason for that is that skin is much less vascularized than something like the heart. So it's easier to create structures that actually recreates that function. With other things, for example, like the liver, I think the time frames would be much longer because we have to really understand the underlying biology of how these cells interact with each other and how these cells function. And that's why the biology is behind our engineering systems, and we have to balance the two and be able to make these tissues actually useful for therapeutics. The major advice that I tell my students is to think about solving very important problems and think about what hasn't been done and how you can do something that's going to really make an impact. And I think if people do that, then they're going to know that the work that they do has the potential to improve human life and make things better. So it's going to be much more stimulating because you know what you do actually matters. I think it's increasing at a very rapid pace. This globalization has really opened up not only borders with respect to trade, but also borders with respect to scientific exchange, whether that's knowledge or actually exchange of people. Myself, I regularly visit many different countries and give seminars. I'm actually involved in one of these exchange programs in Japan, where I go there a few weeks a year, and I actually mentor a number of postdocs there and help them with their development and do research there. So I think these kinds of things are definitely growing, and it's going to be very important for making sure that the research in different countries improves and elevates, and there's sufficient support and sufficient ability to kind of push the frontiers around the world.